right, we'll start or continue with the next and last two presentations of the week, at least here. So we have two visitors, Ricardo and Piotr, that are going to talk a bit about the Guix project and specifically Guix HPC.
Yeah. I'm very happy that you're having me today. I'm not yet an easy build user, but I think our projects have a lot in common and a couple of important key differences that I think are worth looking at so that we can both learn from one another. I would like to introduce Guix HPC, which is really just Guix, but used in a very specific context for reproducible software deployment in HPC environments. Before I start, because I will forget it otherwise, is to acknowledge that I'm here on official business. Like I have to thank my boss for allowing me to take time off to present things here. So, without further ado, functional package management. Guix is a functional package manager, and you've heard of functional package management before, because there were Nix people here yesterday, I think, who explained a little bit about what this is all about. So I'm not going to dwell on this too much, but this is a function. A function takes something as an input and spits out some output. The output only depends on the inputs. It doesn't matter what the environment is like. It doesn't matter if the sun is shining or if the moon is up or if it's cloudy. The global state does not affect the working of that function, only the inputs. Now, in functional package management, we pretend that building packages is very much like working with a function. You give it something, some inputs. In the case of package management, that is the headers, the source files, build tools, libraries, whatever. And out comes something, namely a tree of files, right? Now, if you do this for every package there is, like in this particular case, we've got Emacs, and we have packages that are inputs, right? We've got build tools like GCC or some libraries that Emacs may be using. If we do this recursively, you end up with a very large graph of linked packages. Now, what's important about this functional package management idea is that given the same inputs, you always have the same output under ideal circumstances. Having changed any one of the inputs will yield a different output. This means that if you change the configure flags of your package, you will get a different package. It will have a different prefix, have its own namespace, so to speak. So you can have multiple variants, not only different versions of the same package, installed on the same system without having any conflict. So the same input gives you the same output. Different inputs, different outputs. That's the core idea here. And doing this throughout all of the dependencies, you end up with something like this. Now, actually, it's much worse than that. So this is only for the first bootstrap layer, and it doesn't even include the sources. So this is an actual graph produced by Guix for, I think, the core utils. And it's already leaving out lots of the details. So this looks ugly. So I'd like you to forget about this and think about, it's beautiful? Did you say? Wow, we differ so much. So I'd like to give you some feel for how working with Guix feels like. So I hope you can see this well. Can you see that? So it's customary to greet people first, right? So I don't have the hello command. I can't greet you, but I have Guix, so I can install the hello command. And now I can do that. Greetings. So what happened? I used Guix to install a package. What it said is it will install the hello package at version 2.10. Because apparently there are many different ways to say hello, and it requires.
Can you have 2.29 as well? I would like to see what you do.
Well, if you have the sources for that, sure. Though in this particular case, I only have 2.10 at the moment. And it installs that hello package into a weird directory, namely /gnu/store ... something that I have elided here, which actually looks like this. And then hello, and then the version. So that's a unique prefix that is derived from all of the inputs recursively of that hello package. That includes all of the inputs of GCC that was used to build that, and so on.
Is it also depends on the host system, or is it independent from the host system?
It is completely independent of the host system, which is like it's the core idea here. It says one package in profile. I now have a profile, and that profile looks like this. It's just a symlink under which I have a directory tree. It's a union of all of the packages I have installed. All right. So you don't really have to know about that stuff here, this /gnu/store stuff. This is just considered a cache. Okay. Nobody's ever going to type /gnu/store, very, very long hash, name of the package, version, /bin, /hello. Right. So instead of doing that, we have profiles that contains the union of links to all of those packages that you may have installed. All right. Enough of the practical matters. Right. So who is it good for? Scientists, for example. Scientists want to be able to reproduce environments, but to what end? What's the point of reproducing something? Reproducing is just the first step to get to a point where you can experiment with things. Right? You've got an environment that is exactly the same as somebody else's environment, and now you can take it apart. Now you can say, what happens if I replace this one thing with that other thing? How does this affect the results, if at all? So Guix has a graph rewriting feature that allows you to, say, install the package foo, where instead of all the hello instances of hello in that graph, we replace them with a package called by. All right, so in the bottom left corner you see a little graph there. It's a tiny cut of that huge graph, and for every hello that we encounter in this graph, we just replace it with a by package. And then the user can see how foo behaves under those changed circumstances. So it allows people who care about comparing different environments to accurately modify individual pieces of the environment, leaving everything else untouched. We mentioned profiles before, this .geeks profile thing, which is a link to something somewhere else in the big cache. But that's not the only profile you can have. Obviously, you can have multiple profiles. I think to you that is nothing new. Many tools have that. But it allows you to reproducibly build separate profiles per project. So in one project, you may want to use a particular version of Python. In yet another project, you may want to use a slightly modified version of Python. And you don't ever want to have those things affect each other. They're completely separate. You can describe the contents of that profile with a manifest. Here's an example of a manifest. And you may not immediately notice that, but this is scheme. This is written in Lisp. This really just says, of all of this list of specifications of packages that I want to have, I want to create a manifest out of that. You can pass this to Guix, like so. And it's going to instantiate that manifest. Now, what's not immediately obvious about this is that at this point, all I have to have is a manifest plus the version of Guix. And assuming that the promise of reproducibility is kept, I will be able to exactly reproduce that very same environment that is only symbolically described. I don't have to actually push bits. I don't actually have to push binary images over to somebody else, which may be gigabytes in size. Instead, all it takes is a file like this plus the Guix version obviously availability of sources must be given. This says install me Python, R minimal and hello at this particular Guix version. If those things are there, I can reproduce an environment. Now that's pretty cool.
Ricardo?
Yeah.
Will you get the exact same version as Python? Because that's determined by the Guix release you're using?
That's correct. So Guix provides this huge graph of things, right? And every version of Guix provides its own variant of that graph. Right? As we change Guix, that graph changes, obviously. So if you want to reproduce a snapshot of that graph, you need to know the version of Guix that was used to create it in the first place. With that manifest, as I just said, you can move an environment from one machine to another, or use it on the cluster when you previously prototyped it on the workstation. As long as they use the same architecture, that environment is going to be the same. Yes.
Is it difficult to have multiple Guix versions in the same machine?
No, not at all. It's designed for that.
You just go to the machine and you choose which Guix version you use, and then you install the package.
We have a way to pull a different version from a repository of your choosing. You can specify which commit you want to have. As long as you know that, it is all Git backed, right? So you just say, I want to have this particular version of Guix. Make me that version, and then you can use that. It's not as easy as we would like it to be at this point. So there's still some screws that we can tweak, but essentially it's as simple as using Git without having to know about Git.
Does it require root privilege to install Guix?
Very good point. It requires root to run the daemon. Now, Guix itself, the command line tool, as I've demonstrated it, does not require root privileges, right? Because all it does is talk to a daemon, and that daemon spawns isolated environments. And on Linux, unfortunately, creating isolated environments requires root privileges, because it's an all or nothing affair. You can have user namespaces, which don't require root privileges, but they're usually not available on mainstream systems at this point. So it's not a thing we can rely on. But the daemon itself only requires root privileges for isolation. You could run it without, but then you lose pretty much all of the cool features, right?
The actual build that's going on, that's not running as
That is not running as root.
important.
Right. So Guix just creates an environment for which it requires root, and then runs the build as some unprivileged user. All right, to recap, for scientists, this is interesting because you can have per project profiles. They are fully specified environments. So they include everything, down to the libc, down to the bootstrap binaries that were used to bootstrap GCC. There are no links to the host system. It's an important thing to understand, because an environment that I built locally on my machine is going to be exactly the same as an environment built on another machine, no matter if that machine is running Ubuntu and mine is running CentOS, because all of the packages that are used by other packages are fully specified. Yeah?
Except for the kernel.
Except for the kernel, right. That's one thing that we just pretend does not exist, which is a pretty big assumption. But there are other problems like that where, for the sake of argument, we have to turn a blind eye to them at this point because of the way Linux works. Things like that are easier on systems like the herd. We've got a bit more control, but nobody's using the herd, so there's that. Yet. Getting there.
We support it.
We support it, yes. We are building packages for the herd as well. So if you're a Maverick and you want to start using the herd on your HPC cluster, you got my support. Scientists can describe, share, and reproduce environments without actually having to push bits, other than the bits that describe the environment, obviously. And all of that allows them to go a step beyond just reproducing something. They can actually precisely experiment with the environment. If you have no control over the exact state of your environment, what's the point of benchmarking? What's the point of comparing two different tools if you if everything underneath is kind of vague anyway, right? So with Guix, you actually do see that whole graph, and you can manipulate it programmatically. Developers. Some scientists develop software as well. So, so let's dispense with the labels, right? For developers, Guix has a neat feature which is called Guix environment, which allows you to create an environment necessary to build a package or to hack on a package. So if I do Guix environment hello, it's going to give me not hello, but all of the prerequisites for hello. So I can go and hack on hello. That's really a package that needs a lot of work. Yeah. If you don't want to hack on a specific thing, but you just want to create an ad hoc environment, and you don't really want to commit to installing something, you do Guix environment ad hoc that thing, and it appears in your environment. Another thing that's popular these days is to use the word container. So we use that word too, because we aim to be cool as well. With Guix environment container, you can spawn a container, and let's just do this, right? Guix environment container ad hoc. I want to have hello, obviously, and the core utils. Now it's going to do something. Okay. And I'm root inside of my little world, my tiny container. This does not use Docker. It does not require binary images. It doesn't require disk images on top of which we do things. We just use the store, the big cache, as our disk image. Right? And we can bind mount specific parts of that store, of that cache, into this environment. And here I've got hello, but I don't have Emacs. Right? So that's a tiny environment in which I can run things. It's just user namespaces exposed to the manager.
Can you do this without user namespaces too? Can the daemon give you an environment?
No. But there are different variants of this. So you don't have to use container, but you can use pure as well, which purges environment variables, for example. So it's a lightweight form of that, but it doesn't give you file system namespaces. So that's really useful for developing software and making sure that you don't have any runtime dependencies that access global state. Right? Because if you don't virtualize the file system, your application might still access /user lib something at runtime, and it could cause weird problems on different machines. Good sanity check.
In the environment
Hmm?
version, is it still showing store, or did it relocate everything into your virtual user?
The store, parts of the store are just bind mounted into the container.
Into the normal places or into their places?
Into the usual places. So just exposed. They're not, nothing moves to /bin inside of the container, for example, unless you specifically ask for it. There's more to it. The container command has a lot of subcommands for bind mounting things and exposing certain network interfaces and stuff like that. But that's what manuals are there for. So that's a little deeper.
One of the great things is extremely lightweight. Because normally
Yeah.
in Docker you will have to push all the data. Right? But here you have the store which is already on the system.
You already got the cache, so
You just
why
copy
push
it,
around
right? So
bits?
you
Yeah.
don't copy the data.
Okay, and developers actually sometimes also write code or read other people's code. So with Guix build, you can fetch the sources of a particular package, unpack it, modify it, and then say, build me this package, but with my modified sources. So it gives you what I like to call practical software freedom. It's all good that this is all free software, but what good is it if we don't have an easy way to manipulate it and try it out right away? So developers can also create packs or bundles of binaries produced by Guix and ship them off to somebody for testing, somebody who does not use Guix. So actually pushing bits, which I don't condone, but people have to do this sometimes. So in this case, Guix salmon sailfish star creates a tarball that contains salmon sailfish star, those 3 packages, plus all the dependencies that may be necessary, and only those dependencies. So again, we've got a very precise way of taking a thing in the huge hairball of a graph, pulling at it until we only have those things that directly depend on it. And then we can put those in a tarball, rather than starting with a bigger system image and then whittling it down to the things that we know we need, or that we guess we need, or maybe including some things that nobody really knows what they're there for anyway. If you don't like pushing tarballs and you think fish is not enough, you can add a whale. You can also produce Docker images. So you get all of the features of Guix plus the overhead of Docker.
That's already supported right now.
Yeah, it's supported. You can build Docker images. Yeah.
You're doing that for over a year now.
Yeah, I'm doing this for a pipeline, for example, where we can't really expect people to install Guix everywhere. So we also publish the pipeline as a really fat Docker image of 3-something gigabytes. Some people like that, yeah. I don't get it, but yeah. What image?
Singularity.
Oh, Singularity. Doesn't Singularity also run Docker images? So I guess it would be possible. Yeah, I just haven't found motivation to do it.
The advantage is you don't need Docker at all anymore.
Mm-hmm.
With Singularity, you first have to import the Docker image before you can use it.
Mm-hmm.
And for that, you need root.
Oh, okay.
So spitting out Singularity images directly, then people don't need root anymore to use it.
You just need the set UID helper.
The admin installs Singularity
Okay.
to do that.
Okay.
The user can just run it.
Same with Guix, by the way. The admin just installs the root daemon. Yeah. Yeah. Okay. Okay. Let me know how to contact you, and I'll make that. Yeah.
As a matter of fact, we should have a homepage where you can convert Docker images to Singularity.
It exists.
To do it.
Singularity Hub. You can ask Singularity Hub, take this Docker image and give me a Singularity image.
Mm-hmm. All right. So imagine that there's also another slide that says, for the future, Guix format, Singularity, salmon sailfish star. But then the joke with the whale doesn't work anymore. Mm. All right, HPC admins. It is difficult for admins to devolve package management to users. I understand that, because that's like a very personal thing for an admin to control what software is running on their systems.
Actually, you don't control it at all.
Yes.
You have no idea what's wrong.
It's either or, right? So there's this core packages that they hold on to, and then there's other stuff that they expect users to compile from source anyway because they don't want to touch it.
Wait, the reason we do that is because our users are not able
Exactly.
themselves,
Yeah.
at least not in a very decent way.
Yeah. My usual talk starts with exactly that. The conflict between the sysadmins and the users, who then have to take over sysadmin tasks without being prepared for it. It's a tragic story. Yeah, but to placate the HPC admins, we give them tools to analyze and do the things they do best. Like Guix size, for example. How much space does this need? And why is this so large? What did they mean when they say this is a lightweight tool to do? So with the Guix size and Guix graph, we can obviously look at the size of a package. So see what dependencies it has and how much they contribute to the overall size of the closure of that package. And with Guix graph, you can visualize this. I would like to show you that real quick. Oops. Sure. So here's a profile that I have that currently contains hello, Python, and R minimal. R minimal, what does this look like? Show me the graph. This is an Emacs interface, but you can do this on the command line as well. References. So, this is a pretty graph that visualizes the dependencies of R, for example. This is R and its direct dependencies, and each of these little arcs points to another package, and you can see, what does this thing depend on? So R depends on GNU TLS, and what does this need and why? And you can go as deep as you want with that. So lots of visualization tools that should make your admin happy. And if not, we can add more. Another tool for HPC admins is...
Can you do this all without Emacs?
Sure, yes.
No, Emacs is an operating system.
because you know the basics that we have Emacs people and there are VI people.
Yeah.
No
You can also do this on the command line by manually typing things. It's just a pretty interface for it. I'm an Emacs person. I guess you noticed because even the PDF is an Emacs. Yeah, I know. It's so hard. It is so hard not to talk about Emacs. So. Oh, I don't have a table for that because. But I'll mention it at the end. Okay. Almost there. So Guix GC for garbage collection. Garbage collection removes packages that are provably no longer used. We know this because we use these profiles, and profiles have links to the actual items in the store. And items in the store, packages themselves in their own prefix, embed references to other things. So by just counting references, we know if a package in the store is still used. If a package has no references anymore, it's not linked to anywhere else. So it's not used by anything else. So we can delete it without hurting anyone. That's a real problem in HPC when you install things the traditional way into a global namespace. And you just look at this and you don't know, is this library used by anybody? I just leave it there. Yeah, better safe than sorry. You don't need to do that. You have very precise control. You know what is used and what is not. And you can just tell Guix, remove all that garbage for me. Thank you very much. With Guix GC, you can also look at the references of a particular package. So say you know that one package is vulnerable. It doesn't have patches applied. And you want to know who's using this package. Like, what other package depends on this thing? Right, so questions like that. Analytical questions about the bunch of software, the many, many bits you have on your system, you can answer with tools that just simply come with Guix. So to recap, for admins are freed, obviously, from deciding those difficult questions of which piece of software to install globally, because you don't have global namespaces anymore that are useful. Instead, users decide that.
I have a question here.
Yeah.
I have a question here that they say that no more version variant conflicts, but you know that scientists, as they sometimes write programs, sometimes they want to use specific versions with each other. How does that work? I don't know.
Every package is installed into its own namespace. So you can have different
so
variants of the same package installed on the same system.
And they completely separated.
They're completely separated.
So,
yes.
for example, I can have just a stupid example: Hello 2.10 compiled with I don't know PGI, and then Hello 2.9 compiled with Intel.
Yes, you can have them on the same system. Yes, though in praxis, it is. So in Guix, we provide particular variants of packages. We don't usually go about creating different variant packages unless there's a good reason for it, mostly. Users can obviously change that. They can programmatically change the graph as they please, by just replacing foo with bar, hello with by, whatever. But that's not usually what we provide in Guix.
Okay.
So that requires a somewhat higher level of a user who is willing to interact with Guix as a library. Yeah.
I see. But in theoretical, it's possible.
Yes, it's definitely possible. Yeah. But at the same time, even though users are now in charge of things, admins can still keep track of things. What is used, what is not used, how much space does it take, things like that. At the same time, we are saving lots of space with deduplication. So if you're installing Hello 2.10 and there's Hello 2.9 and they differ in a bit somewhere in a tiny file, all of these files are going to be shared anyway. Now we just deduplicate them. So it's not that much of a burden on this system. So I've been using Guix on a large HPC system with 250 nodes, I think, plus workstations, uncountable, because I don't really know what workstations we have. They all share the same store. People install their software, upgrade things there, and I don't really have to take care of how much space it takes. And it's not because we have so much of it. It's just deduplication works. And HPC admins can finally ditch environment modules. You know, it is fine not to deal with them if they cause troubles. I feel like I stepped on somebody's toes just now.
The maintainer of environment modules is in the room.
Pretend I didn't say that. What I mean is that with environment modules, admins have to provide them in the first place. Somebody needs to actually write them, make sure that they don't conflict with one another. And that idea of managing users' environments for them just disappears when users take care of this themselves, and the system guarantees. Pardon?
Users can write their own modules.
Sure. Well, then it's, I'm talking about HPC admins in particular, and the places where I worked so far was usually the HPC admins' work to make sure a certain set of modules is provided. Yeah. Oh, and environment modules certainly beat the traditional way of users compile their things and fail. You know,
Sorry,
just.
you're making the argument between Scheme and environment modules. I'm not sure that Scheme wins.
Oh, no, you don't have to use Scheme in order to use Guix. It's just a very useful thing to know if you want to go really off the deep end. And that's.
You can just set up an environment. They expect that they're going to make a custom environment for their own software.
Mm-hmm. No, but to set up an environment, all you need to do is install packages. You say Guix package install this.
Their custom software that they've written. So they're writing custom software. The user's a programmer. He's writing custom software, but he's also a biologist and doesn't understand what he's doing.
Right, we are now conflating different roles for users. So the users I deal most with are those who write their own software, but who are mostly users. And I'm also mostly a user of software. So the number of pieces of software that I write is dwarfed by the number of pieces of software that I use. Right. So I consider myself a user for most cases. And you can be a user and not use Guix for development. You know, so there's, these are separate roles. I would consider them separately. And we've been starting to talk already. So, but there are channels for that, you know. So you can always contact me at my email address if you think I grossly misrepresented something today, or if you think I got it all wrong, or if you agree with me, that would be new. We also have a very welcoming IRC chat, so you can join and say hi, ask questions. And you ask a question about Nix and Guix, and I would like to address this. So both Nix and Guix are implementations of functional package management. Nix was way earlier, Guix is way later, which is what. So one core difference that is very important to me is hackability. So Guix is written in Scheme. It embeds in Scheme a domain-specific language for writing packages, for dealing with packages as first-class objects. A lot of the tools that I casually... Yes, so Nix has its own particular language, and instead of this goes a bit more into details than I'd like to, but for Nix you've got one. Mhm. Oh, I'd be happy to use either, as long as functional package management is advanced. I don't really subscribe to the idea of competition. I'd rather think we are.
I'm not trying to, like, what I'd say is, like, from the view of what I saw, the interface is cleaner and better than Nix. Like, I know Nix reasonably well. There's a lot of things with Nix that are just non-intuitive, and, on the command line stuff. But then when we dig into the definitions, like the package definition, it's the same bullshit. So it's like almost impossible for me to, like, sure, I can figure it out, but I'm going to give it to a user, like, not in a million years. And this is to imagine that the only way I can get to the user is through them having to understand this, because they're going to want to create an environment that has their dependencies. This is the use case. They want to put together their dependency list and create an environment that works for them.
So
building their crappy code.
So the domain-specific language that Guix provides it reads very much like English if you are willing to look past the parentheses. And there's an extension for that, that allows you to just not show any parentheses. There's WISP. And it works in Emacs, but it works worse actually than traversing S expressions. So this is one example of a package variant. So it is a package. Ignore this define public thing. This is just how other packages can refer to it. It's defining a variable, FFPWF, that inherits from a package definition that is provided by somebody else. And it overrides a couple of things. It overrides the description, it overrides configure flags, and it overrides the name. And everything else, the user does not have to know. But here it pays off to know about scheme. You don't need that if you just want to have a one-off thing, right? If you want to say, build me this package but with different sources, there's a command line thing for it. You just say with sources equals to that tarball, right? But inheriting from packages is, once you get past the problem of understanding scheme syntax, it becomes very easy. And I say this as somebody who wasn't much into scheme before working on Guix. So I'm not a schemer per se. I like the language. I find it very elegant, which is what drew me to Guix. But you don't need to know it very well in order to work with it. And I have been giving courses to biologists and bioinformaticians who probably shouldn't be writing software, and they didn't have much problem to understand this and use this to their advantage. So there are many people who already use manifests, even though that's already scheme programming in a way, even though it only involves a list of packages, right, and you call a function on it. But yeah, I don't think it's that much of an obstacle compared to learning a completely new language and not having the tools that a mature general purpose language comes with, like a REPL, for example, or debugging tools, what have you.
In our experience in EasyBuild, sometimes people see Python as a hurdle. Comparing scheme to that is...
Yeah.
Scheme is a significantly simple language in Python, like 10x simple.
I agree with that, but I might be biased. I find Python really hard.
It is bigger than scheme.
More syntax.
It's very tricky.
You can shoot yourself in the foot.
What about with heterogeneous clusters? So for example, right now we have 5 different architecture, and in a week we will have 6.
It does not. You cannot use the same Guix package for different architectures. Right? So obviously, the concept of bit reproducibility does not transcend architectures. You can't have the same bits. Obviously, you could have fat binaries, right? That include binaries for each architecture.
You can use the same binary, but you're just not using the hardware properly.
Yeah, right. Or you can have fat binaries that have different variants and ship the whole thing.
It's always
Yeah.
debatable reproducibility because if you change SSC2 to AVX2, you might get a different result. Yeah.
Right.
Yeah, so there's that. There's
It depends
that
on
as
how
well.
far you want
Hmm.
to go.
So you have bitwise reproducibility in terms of the binaries and libraries that you use. Or depending on the system you run it on, they may still produce different stuff.
Yes, and that is true.
It's
agree.
not tricky, it's impossible to fix. So,
But
Yes.
can you mount the store on different machines at different locations?
Um,
Have a machine-specific store, and then you do.
Or you
mounting it properly?
can just put everything in the same store. This is the way it's usually done. Everything has the same store prefix /GNU/store, and it has to be that one, unless you do trickery, which you're going to mention, which is amazing, because we're embedding references, right? Yeah, but in practice, I haven't encountered problems with that. I mean, we have a huge build farm that builds packages for 4 or 5 architectures, I forgot, and they all end up in the same store ultimately. So there's
then the architecture is part of the hash,
right.
in the unique installation. Or
Right, because even the definition of the package itself is part of the input to that ideal function.
That's where you specify which architecture it's for.
No, that is done at builds.
Picks it up, it checks. So what does it do exactly? Does it check the host name? Does it check the proxy info? Does it
No, there's a way to override what target it should build for, and then it cross-compiles.
so you tell it?
Yeah,
Okay.
Maybe I should take over.
yeah, I think so too.